So the change in mass upon heating a small amount of steel wool is small and therefore hard to detect, and therefore it's hard to draw sweeping conclusions. But I know that if you were to run this experiment many times in a very controlled manner, you would find that yes, steel wool does gain mass upon heating in air. And this seems to contradict the theory of phlogiston, which says that steel wool would release something, would release phlogiston in the air. But with this in mind, let's pick up with our story. It's now November 1774. It's a month after Lavoisier was meeting with Priestley, and Lavoisier is now speaking to members of the French Academy of Science. And he starts in, chemists have made phlogiston a vague principle, which is not strictly defined, and because of this, it's able to bend to and fit all explanations demanded of it. Sometimes it has weight, sometimes it does not. Sometimes it is free fire, sometimes it's fire bonded with earth or combined with earth. Sometimes it passes through the pores of vessels, and sometimes vessels are impenetrable to it. This is not a very solidly grounded theory, and so we must found a new chemistry built on a more solid framework which neatly explains fire and air and explains why metals gain mass upon burning and carbon-based substances like trees, candles, wax, and paper lose mass when burned. We need a theory which explains these two phenomena. What are you proposing, Monsieur Lavoisier? Someone shouted from the audience. There is a growing number of members of the French Academy of Science who are dubious of the theory of phlogiston and are seeing the wisdom of Lavoisier's revolutionary proposals. Can you explain these reactions? Somebody from the audience shouted, which all occur in real life. And these reactions we talked about in the launch article. So mercury calc, when heated in a vacuum, decomposes into mercury plus oxygen. This happens. And therefore, you can recombine mercury and oxygen and form mercury calc. This is equation 2. But according to the theory of phlogiston, when you burn mercury or any metal, you get mercury calc and you release phlogiston. So that's equation 3. So how can you explain these, Lavoisier? Lavoisier says, I can explain these, good sir. So mercury calc or any metal calc is nothing but metal bonded with oxygen. So this right there is a new theory, a new idea from Lavoisier. And examples of this, of calcs, are mercury oxide, copper oxide, iron oxide, even gold oxide. These are all metal calcs. So equation 1 now makes sense. When you heat mercury calc, which is just mercury oxide, you are simply decomposing it into its constituent elements, mercury and oxygen. This is how our wonderful esteemed English compatriot Joseph Priestley discovered oxygen, no small feat, no small achievement. And of course, equation 2 is just a reverse. Left alone for some time, mercury, like most metals, will react with oxygen in the air. This is why it gains mass. And equation 3 is just not a thing. There's no such thing as phlogiston. Yes, I just said it. Phlogiston is not a thing. Since oxygen is being consumed when you heat mercury, it can look like phlogiston, the supposed substance which suppresses life and fire, can look like it's being produced. And this, my dear friends, is what I call the oxygen theory of combustion. Combustion reactions happen when oxygen rapidly bonds with anything, metals, wood, paper, anything. The intensity and speed of the reaction when oxygen is chemically bonding with these substances creates so much energy that it is released in the form of heat and light. And this, my friends, is fire.